Section 8.5, Day 1, using the distributive property. Essential question. How do you use the distributive property to factor a polynomial? So the distributive property is the property we learned much earlier in the year. And here's an example of it. So let's say 5 times x plus 2 equals, and then we are distributing to get 5x plus 10. So we are used to going in that order, distributing, and then we end up with our answer. What we are going to do in this lesson is go from our answer back to where we would have started. And the way that we are going to do that is by finding the GCF of the problem, and then what is left will go inside of our polynomial. So our goal today is to figure out what is the greatest common factor, the biggest number that can go into our terms. So for example, the 5x and 10, the biggest number that can go into both 5 and 10 is 5. So that's why the greatest common factor is 5, and then I have to multiply 5 by x plus 2 to get that 5x plus 10. All right, use the distributive property to factor the polynomial. So we've got 9x squared plus 6y. So what I'm going to do in order to find my greatest common factor of 9x squared and 6y is by making a factor tree. So a reminder that a factor tree is figuring out what numbers we can multiply to make that term. So for example, 9, you can multiply 3 and 3 and you will end up with 9. You want to stop as soon as you end up with prime numbers. Remember that a prime number is divisible only by itself and 1. So prime is divisible by itself and 1. So for example, 3 is prime because the only numbers that you can divide 3 by are 3, so itself, and 1. So once you hit a prime, you're going to circle it. Another prime is this other 3. One thing that might be helpful in your notes is to make a list of some of the numbers that are prime. So here's a list of some of the primes. So 1, 2, 3, 5, 7, 11, 13, 17, 19. So that should be enough to get us through the lesson for today. We shouldn't have to go even as high as 11 or 13, 17, or 19, I don't think. So if you see any of those numbers listed in our prime list, it is done. It is simplified as much as possible. All right, so now we're going to write this out. So I've got those 2 3's. So I've got 9 is the same as 3 times 3. And then x squared, you're going to write as x times x. So all I've done now is factored 9 and then expanded it like we did in chapter 7. All right, now I'm going to go over to the 6y. And if you look up top, 6 is not a prime number because there are 2 numbers I can multiply to make 6, 2 and 3. Now if you look up at our list, 2 is prime and 3 is prime. So I'm going to circle both of those. So 2 times 3 makes 6, and then we have a y. All right, now what you're going to do in order to find our GCF, our greatest common factor, is you are going to look at what is in both of our lists, our red list and our green list. So the number 3 is in both of these lists. So that means 3 is our greatest common factor. Then you're going to write your parentheses parentheses, and you're gonna write what you're left with. So what didn't you circle? So we didn't circle a 3, and we didn't circle these 2 x's. So 2 x's would make x squared. In our bottom group, we didn't circle a 2, and we didn't circle this y. So you're gonna put 2y there. This is your answer. So 3 was your greatest common factor in both 9x squared and 6y. And if you multiply 3 by 3x squared and 2y, you'll get your answer. So look, if you multiply 3 by 3x squared, you're going to get 9x squared. If you multiply 3 by 2y, you're going to get 6y, which is what we started with. All right, 25a to the third plus 15a squared. So 25a to the third plus 15a squared. And I'm going to go back and take that list of primes and put it back on this page now so we can keep using it. All right, 25. In order to make 25, I can multiply 5 times 5. And if you look up at our list, 5 is a prime number. So that is as far as I can go. So I have 5 times 5. And then this time I have 3 a's. 15a squared. To make 15, it's 3 times 5. 3 and 5 are both prime. So 3 times 5 times, and then a squared is a times a. All right, let's circle what is in both groups. So we have a 5 in both groups. We have an a in both groups. And we have another a in both groups. So we're looking at what is in both groups. Well, both groups have 5 and 2 a's. So 5a squared is your greatest common factor. In the green group, we are left with a 5 and an a. So 5a is our first term in our polynomial. And then in our second group, we have just a 3. So now we have turned it into a distributive property problem. If I take 5a squared and I multiply it by 5a, I'm going to get 25a squared, or excuse me, a to the third. And if I multiply 5a squared times 3, I'm going to get 15a squared. So I get what I started with. If I distribute this to here and to here. 27y squared plus 18y. Let's bring that list of primes back up. All right, so 27. To make 27, I am going to multiply 3 and 9. 3 is prime, but you'll notice 9 is not prime. It's not in our list. So 9 we can keep going. 9 is the same as 3 and 3. Now we are down to all primes, so I can write that list out. 3 times 3 times 3, because we've got 3 of those circled, times y, and then 18y. Now there's a couple different ways you can multiply to make 18. You can multiply 2 and 9 or 3 and 6. It does not matter which one you choose, you will end up with the same answer. So I'm going to go with 2 and 9. 2 is prime, 9 is not. So turn 9 into 3 and 3. 3 is prime. So now I'm finished. So as soon as you get down to all primes, you're done. So 2 times 3 times 3, and then we have just one y right, let's circle what's in common. We have a 3 in both. We have another 3 in both. And we have a y. So now since I have two numbers, 3, 3, and y for my GCF, I need to multiply those two 3's together. So it's going to be 9y, because 3 times 3 is 9, and then we have that y. Then what is not circled in my red group is a 3 and a y. What's not circled in my green group is a 2. So your answer is 9y times 3y plus 2. 9y was our greatest common factor. All right, this time we have two variables. So 12x squared y plus 20x y. Bring up that list of primes again. All right, so 12, a couple options for 12. You can do 3 and 4 or 6 and 2, whichever one you want. Maybe I'll try 6 and 2 this time. So 2 is in our prime list. Let's circle it. 6 is not in our prime list, so let's change that down to 2 and 3, because that makes 6. So we've got a 2 and another 2 and a 3. Remember, I'm just writing what numbers I circled. We've got x squared, so 2 x's and a y. 20xy, again, I have a couple options. I could do 4 and 5, or I could do 10 and 2. I'll just pick 4 and 5. 5 is prime, so I can circle it. 4 is not, so I'll break that down to be 2 and 2. 2 times 2 times 5 times x times y. All right, we've got a 2 in both groups. We've got another 2 in both groups. We have an x in both groups and a y in both groups. So in both groups, I have two 2's, an x, and a y. So I'm going to do 2 times 2 is 4, an x, and a y. Parentheses. In the blue group, you're left with a 3 and an x. Red group, you're left with a 5. Eight ab squared plus 4a squared b. So what can we multiply to make 8? Well, 2 times 4. 2 is prime, 4 is not, so change 4 to 2 and 2. So we've got 2 times 2 times 2, an a and 2 b's. 4a squared b, so 4 would be 2 and 2. 2 is prime. 2 times 2 times a times a times b. All right, we've got a 2 in both groups, and another 2 in both groups, and an a in both groups, and a b in both groups. So similar to the last problem. So in both groups, we've got two 2's, an a and a b. So 2 times 2 is 4, an a, and a b. So in the blue group, I'm left with 2b. In the red group, I'm left with a, so plus a. So 4ab is my greatest common factor. And then 2b plus a is in my polynomial. Summary. So the summary says, how do you use the distributive property to factor? So we'll say to factor, use the distributive property by making a factor tree to find the GCF. Put the remaining terms in the polynomial.